Hi everyone, hope you're doing well. In today's video, we'll look at solving the leetcode problem, letter combinations of a phone number. To start off, we'll quickly read through the problem statement. Following that, we'll look at an example. Then we'll discuss the logic and write the solution. After that, we'll look at the complexity of the solution. And finally, we'll use an example and step through the solution. So let's get started. In this problem, we have been given a string containing the digits in the range 2 to 9. And we need to return all possible letter combinations that the number could represent. And each digit from 2 to 9 is mapped to some letters. Using the example of 2 and 3, we need to combine each letter mapped to the number 2 to each letter mapped to the number 3 on the keypad. So these are all the combinations that we can generate using the letters mapped to the number 2 and the number 3. The first thing that we'll need to do is to store all of these digits and the letters mapped to them in a hash map, and we will also need to store the combinations in a list of strings. Let's call this result. We can generate these combinations using a recursive approach. We'll first define our key map as a class field so that we can access it from our recursive method very easily without having to pass it as a parameter. Here, my key is the letter 2, which is the digit 2, and value is the string ABC, which is mapped to the number 2 on the keypad of the phone. Let's also define our result string, which we need to return from the letter combinations method. Let's start off by defining a recursive function called generate. The first parameter will be the input which we have received in the letter combinations method. We also need to know which number we are currently processing. So for example, if our input is 2 and 3, then the index of the character 2 is 0 and the index of character 3 is 1. During each call to our recursive method, we'll pass in the current combination, and the index will help us determine the next digit in the input, which in turn will allow us to get the letters mapped to the next number in the input and append them to the current combination. The digit string can be either empty or up to a maximum of 4 characters long. So we need to make sure that we'll only call our generate method if the length of the digit string is greater than 0. The second parameter is the index into the input string. The third parameter is an empty string because I have not yet generated any combination and I'm starting with an empty string. And finally, I need to return the combinations that I've generated. Every recursive function requires a base condition which tells it when to stop calling itself recursively. So in our case, we can see that the length of the input 2 and 3 is 2, and we are combining every letter mapped to the number 2 with every letter mapped to the number 3. That means our combination will always be the same length as our input string. So as a base condition, we can say that if the length of the current combination is the same as the length of the digit string, that means we have formed one combination and we can add it to our result list and exit the recursive call and then go on to process the next combination. This process is called backtracking. Now if our base condition isn't true, that means we haven't built our combinations of letters yet. Let's get the digit at index I from the string digits. Once we have got the individual digit, we can get all the letters mapped to this digit. When I do keymap.get, it returns me a string, but it's easy to iterate to an array, so I'm converting the string to a character array and storing it in my letters character array. Now we need to loop through all the individual alphabets in the letter string, and we will call the generate method recursively to allow it to generate all the combinations with the letters mapped to the next number in the given digits. I'm calling the generate method with I plus 1 as we need to move to the next number in the input digit. For the third parameter, I'm calling the current combination that we have built so far and appending the character that we are visiting from the letter string. Imagine if the current combination had the letter A already in it and we were iterating through all the letters mapped to the digit 3. We would first get the letter D and then the generate method would be called recursively by combining A and D. So this is as far as the generate method goes. Now let's have a think about the time complexity of this method. Now we saw that when we had the input string 2 and 3, we ended up generating 9 combinations. In this case, the length of the input string is 2, and each number in the digit string is mapped to 3 letters. Expressing it in mathematical form, we can say that the number of combinations is 3 to the power 2 equal to 9. However, note that some digits like 7 and 9 are mapped to 4 letters, while some are mapped to 3 letters. So the complexity will depend on the number of combinations that we will generate. So if the length of the input digit string is n, then in the worst case, the number of combinations that we generate is 4 to the power of n. This is especially true for a string with numbers 7 and 9. So for example, if we had our input string as 797, that means we'll have 4 letters for each digit, giving us 4 into 4 into 4 combinations, and that is equal to 4 to the power 3. And we have to also consider the length of each combination. The length of each combination equals the length of the input digits, which is again n. So the complexity will be big O of n times 4 to the power of n. Remember that this is the worst case time complexity we can have. Now let's step through an example and use the input string 2 and 3 and see how our recursive function works. Now let's do a sample run of this code with the input string 2, 3. So the first call will be like this. Inside the generate method, we notice that the base condition is not fulfilled because the length of the current combination is not equal to the length of the input digit. We'll fetch the letters mapped to the digit 2 and we get A, B, C. For each of these characters A, B, C, we recursively call the generate method to combine these with the letters mapped to the next number in the input, which is at index I plus 1, that is 1, and we get these 3 calls. Now at this point we can visualize these calls via a tree here. So we start off with an empty string and we append A, B and C. All these are the letters mapped to the number 2. Now let's consider what happens inside the call here. The base condition is not fulfilled because our combination's length is less than the number of digits in the input. We will process the number at index 1 in the input, that is the digit 3. We'll get all the letters mapped to it in the key map and we get D, E and F. We recursively call the generate method again. Remember, for this call, the current combination string already contains the alphabet A here. This time, we will append the letters to the current combination string and also add 1 to the index to get 2. So the recursive calls will be. So here we are combining the alphabet A with each of the alphabets mapped to the number 3. So we can visualize this with a tree like this. A is combined with D, E and F, and all of these are the alphabets mapped to the number 3. In these calls, the base condition will be fulfilled because the length of the current combination is 2 and the length of our input digit string is also 2, and our code will now backtrack, that is we add the combination to the result list and return from the method. This is why it is called a backtracking algorithm. Now when we backtrack, we will process the letter B mapped to the number 2. Remember that we are still inside a recursive call. Just like with A, we will do 3 more recursive calls with B as well. So these are the recursive calls when I have backtracked and we are now processing the alphabet B and combining all the alphabets mapped to the digit 3. And in this case, our visualization will look like this. So B is combined with D, it is also combined with E, and finally it is combined with F. The base condition will be fulfilled for each of these calls now, and the combinations will be added to the result list. Note that we still haven't finished processing the last character mapped to the number 2. The last character mapped to the digit 2 is the character C. This will lead to 3 further recursive calls like so. This time we are appending D to the alphabet C. And similarly, we are appending E to the alphabet C and F to the alphabet C. In a visual representation, this will lead C being followed by T, then another call where C is followed by E, and a third call where C is followed by F. And now the generate method will backtrack because the length of the combination is equal to the length of the input digit string. At this point, we are done processing all the letters mapped to each digit in the input string. I hope you found this video useful. Please do leave a comment if it helped you, and please do subscribe to my channel. It helps me a lot, and like and share my videos. Thank you.